So let's highlight some areas. So first of all, you might notice there's a lot of, you might think it's a lot of words here. In maths proofs, there are supposed to be words. If there's just equations and no words, well, depending on the problem, but most of the time there should be at least like words here and there. So first we do the base case. We don't necessarily say this is the base case, but we say if n equals 1, then we say the statement we want to prove is that which is true. Usually the base case is easy, sometimes not. In this case it is. And then notice the way we do the induction step. So we say, assume it's true for n, and then we write down what that means, what that gives us. Cool? And then, so then we want to prove it for n plus 1. We don't need to write down what we're trying to prove for n plus 1, but we should start, first of all, with the left-hand side of what we're trying to prove for n plus 1. So we start with that, write down as it is for n plus 1. Then we do manipulations, and here we apply the induction step, and we get n plus 1. And then we say, so it's true. And then the last step, we always need to wrap it up to give it, like, you know, when you write an essay in English, you have a conclusion at the end. So here you say, hence, by mathematical induction, because that's what we used, hence, by mathematical induction, the statement is true for all natural numbers n. Cool. So that is how you would write this out in words. Well, that's kind of the model solution. Yours can be slightly different. So I think, so, okay, let's note, oh, I should use this. I should mention that, okay, remember the P of n that we're talking about here, P of n is not an expression. So, okay, so this, like this left-hand side, that's not P of n. And P of n is not this on the right-hand side. P of n is this whole statement. Okay, so that's important to understand. P of n is not an expression or a formula, it's a statement, something that we're trying to prove. So I think I saw one or two of your solutions that you wrote down. You would do something like, okay, so for the first step, we prove that P of 1 is 1, which I guess what you meant was that P of n is this left-hand side, and you prove that the first one is 1. Okay, so just be clear about what the statement is that you're trying to prove. Cool? Cool. So let's do some slightly more or less trivial examples. Any questions, remarks, comments, insults? Okay, good. Which one do you want to do?
The second one.
Okay, hands up for the first one. Hands up for the second one. Okay, first one it is. The tribe has spoken. Why the first one, by the way? Does it look cooler? Okay, so first one. So this is the statement we want to prove. What's the smallest value of n to which we can apply this? 1, 0, 0? Does this make sense? The statement makes sense if n is 0. Okay, I've got no, then I've got the yes. Okay, so you see the powers here are powers of 2. I mean, the exponents of x are powers of 2. So here it's 1, 2, 4, 8, up until 2 to the n. So the first term here, which is 1, is 2 to the 0, which means the smallest value of n for which we could do this is n equals 0. So you can do as your base case n equals 1. Then that just means that when you do the proof, you only proved it for 1, 2, 3, and those positive integers. You haven't proved it for 0. You could do 0 separately if you want to. You know, whatever tickles your fancy, and yeah. Okay, so n equals 0. The left-hand side. Okay, so that might help you if you want to do it this way in proofs. If you want to prove that something is equal to something else, you can do this way of saying the left-hand side, and then writing down with the left-hand side, doing fancy magic, and then at the end you say equals to the right-hand side, assuming you've got on the right-hand side. So left-hand side, when n is 0, that's 1 plus x to the 1, and the last term is also 1 plus x to the 1, because 2 to the power of 0 is 1. 0 to the power of 2 is not 1. So 1 plus x. On the right-hand side, we have 1 minus x to the power of, what's 2 to the n plus 1? So that'll be 2 to the 1, because 0 plus 1 is 1, so that's x squared over 1 minus x. Now, is that true? Is that true? Yes. That is difference of squares. You can factorize 1 minus x, 1 plus x, the 1 minus x cancels, and you get 1 plus x. Okay, so this is true. So n equals 0 is true. And now we're assuming it for, okay, so we assume it for n. So in other words, we're assuming that 1 plus x squared, up until 1 plus x to the 2 to the n is 1 minus over 1 minus. Okay. So now we want to prove the same for n plus 1. So we start with the left-hand side, which is 1 plus x squared, up until 1 plus x to the 2 to the n plus 1. Okay, now how can we use our induction hypothesis? Yeah.
Okay, so we know that up to 1 plus x to power by 2 power by n plus 1 will give that formula there, right? So we can just then multiply that formula with the next one, with n plus 1, which would be 1 plus x power by 2 power by n plus 1. And then we can plug that in the...
Okay, so I'll stop you there. Thank you.
I think I went a step ahead. Yeah.
Cool. Okay, so we're multiplying a lot of terms here. That's the last term. What's the second last term? Okay, so we can write it out from the start. What's the second last term? Okay, so 1 plus x to the power of 2 to the n, and then we've got the last term, x to the 2 to the n plus 1. So now we see this first part, we can use our assumption. We assume that that is equal to that. So 1 minus x to the 2 to the n plus 1 over 1 minus x times 1 plus x to the 2 to the n plus 1. What do we do next?
Oh, wait, yeah.
Other than you. Sorry, but yeah, you.
You times by 1 plus x to the power of 2 and plus 1.
Sorry, what?
You times the right hand side. Wait, what was it?
Okay, so we've got here, what do we do next?
Multiply that.
Okay, you could multiply out. Not a bad. What's a better way to do it? Difference of squares. Difference of squares. So here you see you've got something minus something else, and then that plus the same thing. You got 1 and 1, x to the 2 to the n plus 1, x to the 2 to the n plus 1. So your eyes should always be on the lookout for these sort of things, these patterns. So, okay, so just ignore that. So, you know how difference of squares go. A minus b times a plus b is a squared minus b squared. So the first one is 1 squared minus, then we have this part squared.